So, last class I was discussing about the bearing capacity of layered soil, and I solved the second case, that is the stronger sand and the bottom layer is the weaker clay. Now, this class I will solve the third case, that is this is the case 1 that I have solved, stronger clay versus weaker clay, then stronger sand versus weaker clay. Now, the third case, this is this is case 3, which is phi versus phi. That means, we are taking a stronger sand, the same properties, that my gamma 1 sat is 20 kilonewton per meter cube, then gamma bulk 1 is 18 kilonewton per meter cube, then C 1 is 0 and phi 1 is 40 degree. Water table is again at the base of the foundation. Foundation is 2/3 rectangular foundation. Now, you are given the second layer, which is where which is definitely will be below the water table. So, gamma 2 sat will be equal to 19 kilonewton per meter cube, and C 2 value is 0, phi 2 value is 25 degree. Okay. So, phi 2 value is given as 25 degree. Now, we have to again determine the Q ultimate. Okay. The same equation will also basic equation will be also valid for this case, because we have not changed the other properties and the top layer is also sand. So, that is why C is 0, C 1 and C 2 both are 0. So, this basic equation you have to again we can apply. So, that basic equation is Q u and Q b plus gamma dash h square 1 plus b by L, then 1 plus 2 df by h, gamma b by gamma dash, then K s tan phi divided by b minus gamma 1 h. So, this part I will discuss later on, but right now I am writing gamma 1 h. Okay. So, now the Q b, that is the bearing capacity of the bottom layer. So, that will be the first time will be definitely 0, because now it is cohesionless soil. There will be second term and the third term. So, second term gamma 1 I am writing the basic equation, later on I will modify that. The gamma 1 df plus h, and then in Q 2, then SQ 2 plus half gamma 2 because this is gamma 1, gamma 2 b in gamma 2 into S gamma 2. Okay. Now, for phi equal to 25 degree, NQ is equal to 10.7 and N gamma is equal to 6.8. Okay, that we are getting. So, SQ and S gamma I will get 1 plus 0.1 b by L into tan square 45 degree plus phi by 2. So, that is equal to 1 plus 0.1, b is 2, L is equal to 3, then tan square 45 degree plus phi value is 25 degree. So, this will be 25 divided by 2. So, this is coming 1.164. So, now I will calculate the QB. Now, as I mentioned in this equation I have written the general way, but now the gamma is different or this 18 and the df part is one gamma and h part is another gamma. So, that is why I am writing in different form. So, that is equal to 1 into 18 plus 20 minus 10 or 10 into 1. So, that is the Q surcharge, and then NQ2 is NQ2 is 10.7 into SQ2 is 1.164 plus half, then Q is the gamma below the water table, gamma sub. So, this is 19. So, 19 is the unit weight. So, second layer. So, 19 minus 10, width of the footing is 2 into 6.8 is bearing capacity factor, then again 1.164. So, QB is coming out to be 420 kilonewton meter square. Okay. Now, QT calculating, and QT value will be the initial QT value was QT 2732.7, because here also it will be again 2732.7, because and all the values are remain same, because it is not changed, and the position of the water table also not been changed. So, QT value will be 2732.7 again, because initial case also 32, this is 2732.7. So, here also 2732.7. So, the QT value is not changing, because we are using the same sand and the same water table position. Now, the Q2 by Q1, that will slightly change now. Now, what is Q2? So, Q2 value is Q2 value is will be both are sand and on the surface of each layer. So, this is first and second term are 0. Then the third term, this will be half into gamma 2 B in gamma 2 and divided by half gamma 1 B in gamma 1. Okay. Now, what is gamma 2? What will be gamma 1? Because the gamma 2 is below the base of the water table, below the water table. So, definitely it will be gamma dash. Okay. So, now if even if we put in the surface, so we have to put it below the water table. So, that is why I can write, because half B will cancel out. So, only there will be gamma 2 and in gamma 2, and there will be gamma 1 and n gamma 1. Okay. So, now gamma 2 here I am taking 19 minus 10 gamma dash, because it is below the water table, the second layer, and the gamma 2 for phi, gamma 2 is 6.8. Okay. And then gamma 1, again I will take gamma dash, because again like the case 2, the water table position is not changed. So, I will take gamma bar, which is equal to 14. Okay. So, gamma bar, this value is equal to 14. So, I can write that this gamma dash value is equal to 14. So, I can directly I am writing this value as 14. Okay. So, this is 14 into, so this is 93.7. So, in previous problem you can see it is 93.7. Okay, 93.7. So, this value is roughly coming out to be 0.044. Okay. So, now we will go back to that chart. So, 0.044, where is the 0.044? This is 0.044 means roughly 0.05. So, this is 0, so this is 0.2, this is 0.1. So, this will be your 0.04, which is close to here. So, this value is here and that will be roughly 2. Okay. So, K's value will be, so K's value will be around 2. Okay. So, K's value is around 2. So, now I will calculate the QU value. So, QU value will be 420 plus gamma dash is 10, A square is 1, then 1 plus 2 by 3, then 1 plus 2 into 1 divided by 1 into 18 divided by 10 into 2 tan 40 degree divided by 2, then minus 10 into 1. So, this value is coming out to be around this value, and one thing that during my calculation I have taken this is 5. So, there will be some higher value that I am giving. You just calculate this and you will get the actual value. Okay. So, this value you calculate, okay, and then you will get the actual answer, because I have done the calculation with taken k is equal to 5, because when I pick the value of Ks from the chart. So, there I have taken 5, but actually it is 2, because you can see the value corresponding to 0.04, which is close to 0. So, it will be around 2. So, K's value will be 2. So, you just calculate considering 2, just do the calculation, you will get the value of Q ultimate or ultimate bearing capacity. Now, one thing I want to mention, that when during the derivation I told you that this I am taking this basic equation where I am giving this is gamma 1 H, or here it will be gamma dash H basically. It will be gamma dash H because it is below the water table. Now, this as per my understanding, this gamma dash H we are subtracting. Why we are subtracting? Because we have taken the effect of H in the QB calculation. You can see when I calculate QB, I have taken this H, because this is H equal to 1. This is nothing but that gamma dash into H, which is I am just subtracting here. Okay, which is I am just subtracting here. Now, this is if I subtract directly gamma dash H, if it is a clay soil, then there is absolutely no issue, because if this is a clay soil, then this NQ is 1, then safe factor is also 1. You can see that if it is a clay soil for case 1. So, you can see that NQ is 1, your safe factor is 1. So, this total only the gamma into the depth, df plus h, but there is no other factors. In such case, subtracting gamma into h is absolutely fine, there is no issue, because you are considering the h effect during the QB calculation, that you are subtracting in the main equation. So, it is balanced, because you have not, because this h effect is already been considered during the soil friction calculation. So, it is better to do not consider this twice, to neglect that. So, that is no issue, but if you do the same thing for the sandy soil, then I think it is not the right approach. You have to do some modification. What is that? Why and we have to do the modification? Because in QB calculation, now your safe factor and the bearing capacity factor are not 1, both are not 1, they are basically some value. Okay. And now, if I only subtract gamma dash into h, basically I am subtracting some, I am not subtracting the total contribution of h that is considered during the QB calculation. So, So, I am subtracting less because those multiplication factors are not used in the during the subtraction. So, because this equation is initially developed for bottom layer is clay. So, my suggestion that when you calculate, when you do this type of calculation, so instead of using gamma dash h, you just use during the subtraction that gamma dash h into your n gamma 2 into s gamma 2. Okay. Or in another way, you just consider this first part, don't, because this is the same part that I am subtracting. As I mentioned, you can do in two ways, either you do whatever way I have discussed, otherwise during the cubic calculation directly don't consider this part. Okay? Don't consider this your second term, don't consider this part. Okay? So, you don't consider this part means this part. Don't consider this part. Okay. If you don't consider this part, then no need to subtract anything. Okay. Then this part, you have to end the equation here, and don't consider this part. You have to consider only up to this part. Don't consider this one if you do it in this way. Otherwise, if you consider the QB part during this second term during QB calculation, then you have to subtract. And if you subtract only gamma dash into H for clay soil, I think there is no problem, but sandy soil, as per my suggestion, you calculate the n gamma 2 and s gamma 2. You incorporate n gamma 2 and s gamma 2 within this calculation also. So, now if you incorporate that, then your equation will be QB will be, again I am just writing that, you do the calculation later on, that is half into 10 into 1 plus 2 divided by 3, 1 plus 2 into 1 divided by 1 into 18 by 10 into 2 into tan 40 degree divided by 2. Now, minus 10. Now, NQ gamma and this part is what? NQ gamma is 10.7 and SQ gamma, N gamma 2. N gamma 2 is 10.7 and S gamma 2 is 1.164. So, I have to multiply these things also, 10.7 into 1.164, 1.164. So, that will be your answer. So, in few researchers have suggested that you use the first one, that means if I write equation A and equation B, and few cases it is suggested that you use equation A, whether the soil is clay or sand, you just multiply directly gamma 1 into H, but and few have suggested that you go for second option, that is B. So, I will recommend it you go for the second option. Okay. So, that is one thing that I want to mention, but this calculation I have not done, you just do the calculation, I have given the values, you will get the value. So, now this is the these three cases are completed. Now, quickly I will give you the bearing capacity for other types of foundation, because I have discussed the only rectangular foundation. Now, square foundation, it is very simple. In the rectangular foundation, that the equation I have given or the calculation that I have done, in that case you put just B equal to L equal to the value. So, that means that the rectangular case will be converted to the square case. So, square case is very simple, that I am not discussing. You have to put only the B equal to L equal to the value. Now, I am doing for the strip footing case and the circular footing case. Now, I am among these three cases that I have discussed, I am taking case 2, that is my case 2 for this calculation, I mean for other footings, because that means your top layer is stronger sand and the bottom layer is weaker clay, and the properties are same. Position of the water table is also at the base of the foundation, dimension of the foundation is now will change. Now, in the strip footing, the B value is 2 meter, because it is a strip footing, so L is not required. So, it is a strip footing case. So, this is for case 2 I have taken. First one I will do for strip footing. Okay. So, that means I have taken B is equal to 2 meter. So, if I take B equal to 2 meter, now it is the case 2, the QB will be what? Q will be 40 into 5.14, and in the previous case when I solve the case 2 problem, so I have taken a shape factor 1 plus 0.22 into divided by 3. So, that shape factor is not required. Okay. So, that means here I will take your this will be 1, because it is a strip footing, then plus 18 into 1 plus 20 minus 1 into 1. So, that value is 233.6 kilonewton per meter square. Okay. Now, QT also I can calculate. So, QT value is 18 into 1 into 64.1, then the factor is 1, because QT value for case 2, this is the QT value 18 into 1 into 64.1 into that shape factor. Now, shape factor is 1. So, both the shape factors are 1. So, I am just putting that shape factor is 1. So, this shape factor is 1, then plus half into 20 minus 10 into width is 2 into 93.7 into 1. So, that is 2091 kilonewton per meter square. Okay. Now, again in whether the footing is strip footing or the square footing or rectangular footing, because Q2 Q1 determination we are going for the strip footing all the cases. So, because previous case also I determined that. So, this case also QT by Q1 will not change. So, this is 0.16 and Ks value is roughly 3.5. So, now if I put this value, I will get the QU, that is 233.6 plus this is 10 into 1, then the shape factor is 1 into 1 plus 2 divided by into df by h into q bulk by gamma bulk by gamma dash into 3.5, tan is 40 degree, tan 40 degree divided by 2, again minus 10 into 1. So, that is equal to 291 kilonewton per meter square. So, in case of rectangular footing, the value was 363. So, definitely for strip footing it will reduce. So, it will be 291 kilonewton per meter square. And again I want to mention that this A case and B case, so these modifications is you have to do if the bottom layer is sand, okay, only, but otherwise it is not required. So, now next one I will go for the circular footing. So, for the circular footing I will go the same calculation with your diameter or width is equal to 2 meter. Circular footing with diameter 2 meter. So, now in this case I have given the equations. So, I can calculate the QB is given 1.2 C2 NC2 plus gamma 1 dF plus H, because this is the general type of equation. And then I am writing here 1.2, C2 is 40, then NC2 is 5.14, then plus this is 18 into 1, 18 into 1 plus 20 minus 10 into 1, so that is 275. So, that value is coming out to be 275 kilonewton per meter square. Now, QT value also I have given the equation for the circular footing. So, QT value, that equation is gamma dF into NQ1 plus, now the change is 0.3, strip footing it is 0.5. So, it is 0.3 gamma 1 B in gamma 1. Okay, so, now I can write gamma bulk, because it will be the within the depth of the foundation, dF is 1, NQ1 is 64.1 plus 0.3, then this value is below the base of the foundation. So, gamma will be 20 minus 10 with, or I should write D here. So, that D value is equal to 2 meter into 93.7. So, into the again yes, gamma 93.7. So, this value is 1716 kilonewton per meter square. Okay. So, now I will calculate the QU, which is QB plus, now this equation is given 2 gamma H square 1 plus 2 dF by H S Ks tan phi divided by B minus gamma 1 H. So, this is the equation was given in previous class. So, one of the previous classes. So, this equation you see for the circular footing, Q ultimate equation is given, but this case as the top layer is sand. So, we have to do the modification and top layer is sand, and this is also for top layer is sand, but here the water table is there. So, we have to do the modification. So, that modification is the same as this will be QB plus 2 gamma dash H square 1 plus 2 dF by H into gamma B by gamma dash into S Ks tan phi divided by B minus gamma 1 H. Now, as I mentioned that your S is equal to 1, but that is a very conservative case. So, for you can, for conservative case you can consider is equal to 1. So, that means S can be taken as 1 for very conservative case. Okay. So, if I consider that conservative case, then it will be equal to QB is 275 plus 2 into 10 into 1, 1 plus 2, 1 divided by 1, this is 18 divided by 10, S I have taken equal to 1, and Ks again it will be 3.5, because that I have already mentioned for different case of footing also. We have to consider QT by Q1 for strip footing. So, this is one conservative solution, then this is 3.5, then tan 40 degree divided by 2. I should write this is also B or D. So, this is 2. Yeah. So, then minus 10 into 1. So, this value is 400 kilonewton per meter square. So, that means this is the 3 cases I have discussed, for the strip footing, circular footing, then for rectangular footing by putting B equal to L, you can convert it to square footing also. So, these are the bearing capacity equation for layered soil, and that we can can be used to determine the bearing capacity if there is a 2 layer case. Okay. So, in the just one part is remaining for this bearing capacity calculation, and that is the 4th case, because I have discussed 3 cases, and then during my discussion also I have told that there is a 4th case. So, that is a separate case which is not same as case 1, 2, 3. The 4th case is different. In the 4th case, the top layer is the stronger layer, weaker layer, and the bottom layer is the stronger layer. So, the 4th case I will discuss in the next class, and then I will start the next module, the next part, that is the settlement of the foundation. Thank you.